All right. The central limit theorem states that if a sample size is large enough, the sampling distribution model of sample mean from a random sample is approximately normal, regardless of the shape of the population's distribution. The t-distribution is similar to the normal curve, except that when the degrees of freedom changes, the shape of the t-distribution changes. Degrees of freedom is a sample size minus 1. The smaller the degrees of freedom, the fatter the curve, so the area under the tails is greater than in a normal curve. As a result, the 68, 95, 99.7 rule does not apply. As the degrees of freedom increase, the t-distribution approaches the shape of a normal curve. This happens quickly when the degrees of freedom equals 30. The shapes are almost identical. So, I'm going to go with this. Estimate each of the following. So the critical value of t for 95% confidence interval when the degrees of freedom is 7. So we are looking for t star for 95% and degrees of freedom of 7. So we are looking for the two-tail probability. It'll specify like if it's one of the other ones, but so the two-tailed one for 95% would be 0.05, and then degrees of freedom 7, so you'd go to 7 and then down from 0.05, so 2.365, so it would be this one right here. So this would be t star is equal to 2.365. B, critical value of t for 99% and degrees of freedom 102. So if we look at our table here, okay, it's going to be the one for 0.01 for two-tailed, but do I have degrees of freedom for 102? No. So when that happens, we go down. So we're going to consider it as 100. And that would be this 2.626. So t star is 2.626. And so this is for degrees of freedom being equal to 100. And I'll just make a note. We go down in degrees of freedom if it is in the middle. Like of two values is what that means. All right, now these next ones say the p-value for t less than or equal to 2.19 with degrees of freedom 41. So this one we actually have to do something a little different. You're going to need your calculator. And you're looking for the function TCDF. Yeah, so it's the same place you would have gotten normal CDF and geometric PDF and all that stuff. So TCDF, the lower can stay because this is less than or equal to, so the lower is going to give you negative 1E99. And then upper, you'll put in this number, so 2.19. Then degrees of freedom is 41. Now, if degrees of freedom wasn't given to you and they gave it to you as n, you would need to subtract off 1 for that. But they're giving it to us exactly, so we can just do that. Set negative 1E99. And that number is 0.983. And again, that's the p-value. Then D, the p-value for the absolute value of t being greater than 2.33 with degrees of freedom 12. Now, what does that absolute value do? Okay, it makes it positive. So what value of t can be in there? Okay, it's going to either be positive or negative, right? So the answer could end up being negative 2.33 also, right? But it's obviously going to end up being the absolute value, so it's going to become positive no matter what. But when I look at this, I need to account for both sides of this, okay? Because it's going to be some on one side and some on the other. So this one, since I have two areas where it's more than 2.33, okay, one in the positive and one in the negative direction, I actually multiply the whole thing by 2. So it's going to be 2 times TCDF of, since it's greater than 2.33, and then the 1E99 is fine, and 12.
Wait, why are you multiplying it by 2 again?
Because there's two spots where it would be greater than 2.33 since it's absolute value.
Okay.
Because in one sense, technically one of them is less than, because the negative one, because when you have an absolute value and an inequality, you flip the sign and you flip the inequality and change the sign. So we're accounting for both by multiplying the whole thing by 2. So when I do that, I get approximately 0.038 as my p-value. All right. The assumptions for using a student's t-distribution, again, that's just the name of it. I don't know why it's called that, but that's what it's called. So our assumptions, we have an independence assumption. We have a random assumption or representative sample. There's the 10% condition. It is nearly normal. How do we check that?
Using the normal model.
It's in the notes. I think remember what we said on Friday. Or what you read on Friday.
If you check a histogram, always draw one. If n is less than 15, histogram should be closely normal. If 15 is less than n, which is less than 40, okay if histogram is reasonably symmetric. If n is greater than 40, safe unless we have extremely skewed data.
Yeah. And so, I think I said this, but we don't necessarily always draw it, but you at least need to think about it or like look at it or something like that to point out that it's nearly normal, meaning unimodal and symmetric. Now this next thing you're going to want to make note to make sure that you know this formula. The confidence interval using the student's t-distribution, so the the confidence interval is y bar plus or minus t star sub df, which is degrees of freedom, times s over the square root of n, where s is the sample standard deviation. so we'll just leave that there for now. Does everybody have this? All right, hoping to lure more shoppers downtown, a city builds a new public parking garage in the central business district. The city plans to pay for the structure through parking fees. During a 2-month period, 44 workdays, daily fees collected average $126 with a standard deviation of $15. What assumption must you make in order to use these statistics? Okay, so basically, again, are our assumptions met? We don't really need to write them out. We wrote the assumptions on the last page. But are they met? Is it independent? Is it random? Is it seem like it would be nearly normal since it's 44 work days? Yeah, since that's greater than, we can assume that. What was the last one? 10%. So, yes, so we can just say conditions met. And yes, on the exam, you should actually write them out. But so write a 90% confidence interval for the mean income this parking garage will generate. So I want to write down a few things. I'm going to do this by hand and then also with the calculator for you. So the things that I know about this, what are my degrees of freedom? 43, because it would be n-1. Now, looking at your t-table, is 43 an option? No, so what are we going to use? What's the next closest thing less than that we're going to use? 40. So I'm just going to make a note here that I'm going to use 40 when I'm looking at it. Now, I want to say maybe your calculator does round it down. I'm not sure. Your answer could potentially be a little off by like a few decimal places, depending on if that table has actually all the values that are known or if your calculator's using a more specific value. So just know that it might be off by like a little bit potentially, but I think for the most part your calculator will just use the same ones that we have here. But anyways, just for reference for you. So our Y bar, okay, from our formula is the average collected, so that's going to be 126. So Y bar equals 126. Gosh, I'm tired of these bugs. There's more of those stupid fruit flies. I don't understand. Just keep appearing. I don't get it. I swear they're only over here too. So. Okay.
What's the set of that hand sanitizer?
Lemons.
Does it attract that?
I mean, I don't think so. It's capped, so I've had lemon hand sanitizer on my desk for like 2 years, so this is a new problem. So there's actually a hole in the window though, so I'm thinking that might be where it comes in, where they come in at, but I'm unsure. Anyways, what's the standard deviation?
15.
And n is equal to 44, just again to show where we got our degrees of freedom from. All right, so what?
When Joy's mad at me, she goes, you get an X. And I'm like, what? I don't know what that means.
All right, so Y bar, so that would be 126 plus or minus. So what is the degrees of freedom value for 90% confidence interval at 40?
1.684.
Yep, 1.684. And then S over the square root of n, so 15 over the square root of 44. And so you could work that out if you want to. The calculator function is going to be t interval From that one, you go to stat test. I think so, yeah. And then you'll go down to number 8 is T interval. Now, it's going to ask you if you want to input data or stats, okay? For this one, we have stats. Data is when they've given us information that we need to put in lists, okay? So that can be a difference with this versus the other stuff that we've had in the previous sections. But for this one, they give us stats, so that's the first thing. You want to make sure that's highlighted. X bar is going to be our Y bar. So this is X bar here. S is going to be S sub X on the calculator, just for reference. N is the same in confidence level. So this is going to calculate degrees of freedom on its own based on the N value that you give it. That's why I said it could be off by a little bit, because we're not putting in the degrees of freedom. We're just putting in the N value. So X bar on your calculator is Y bar on our paper and in our formula. So that's 1/26. The S sub X is RS, which is 15. N is 44. And confidence level is 0.90 for this problem. And so then it's going to produce 122.2 and 129.8. Now, if you actually run this up here and check it, it probably will be close. It might be exactly the same. I'm not sure. But obviously these decimals didn't keep going. That's just what showed up on the calculator. So it might end up working out exactly, but it might be rounded too. I don't know. All right, so then explain what this confidence interval means. So based on the sample, I am 90% confident that the average daily revenue for the garage will be between $122.20. So notice it's money. So even though these ended on an even decimal number, I need to make it as it would be money, to $129.80. So then explain what 90% confidence means in this context. Specifically, 90% of all random samples of size n is equal to 44 would produce intervals that contain the actual mean daily income of the parking garage. So then the last one for this question, the consultant who advised the city on this project predicted that the parking revenues would average $130 per day. Based on your confidence interval, do you think the consultant could have been correct? Why? Why?
It's not in our.
Correct.
What did she say?
She said no because it's not in our interval.
That is what she said.
$130 is not in our interval, so it seems high. And we're only at 90% confidence. What happens the higher we go? Hmm?
The interval would get bigger. I mean, if we had a bigger confidence interval, then 130 might be in it.
Right. But for this particular situation, it's not. Oh, this problem continues, I guess.
Oh.
Well, what did we look at that?
I assume that was brilliant.
I thought it was too.
It's like those commercials are like, but wait.
Wait.
Josh, did you have all that? I realized I just took it off the screen. Okay. Okay, well, suppose that for budget planning purposes, the city needs a better estimate of the mean daily income from parking fees. Someone suggested the city use its data to create a 95% confidence interval instead of the 90% confidence interval first created. How would this interval be better for the city? How would this interval be worse? So, how is it better?
The $130 would be an interval. It was bigger.
It could be, yeah.
It has like a bigger range, so it could
Bigger
show
budget.
more positive results and also more negative results, so you get a wider range of what it could be.
Yeah, so both of those things kind of combined. It's wider, so it's more likely to capture the true daily average income, which in turn would suggest that or would likely include the $130 because we were at, what was it, $129.80 or something like that. So it was like, I mean, it was barely outside of our interval. So we can, I would say, pretty confidently say that it will be in our interval when we widen it. And then why is it worse? It's kind of an obvious thing.
Well, it's not as precise as
Right. Yeah. It's wider. So it's less precise.
So being wider is good and bad.
Yes.
Depends on
Basically.
what you want from it.
Exactly. If you just want to prove your point, then
Then it's great.
Great.
But if you want accuracy
Yeah.
or precision,
how could they achieve an interval estimate that would better serve the planning board?
get a bigger sample,
What do you mean?
like increase the number of days you check.
Yeah. Increase sample size by collecting for more days. Because realistically, it says they collected for 2 months, which were 44 work days. But they didn't tell us, you know, was this January and February? Was this, you know, June and July? Like, obviously, there's some places that are busier different times of the year. So by just simply looking when they did, it's obviously, you know, we don't know when it was, so it might get better, it might get worse, who knows. Let's see. Next one. Software analysis of the salaries of a random sample of 288 Nevada teachers produced the confidence interval shown below. With 90% confidence, I guess the teacher pay is between $38,944 and $42,893. Explain carefully what the software output means. Anybody know?
So like I guess that we have, like based on the sample we have 90% confidence that the average salary for teachers in Nevada is between $38,944 and $42,893.
Yes.
I was confused. I was like, can you not read the numbers?
We're
Or, like-
90% confident that the average teacher salary in Nevada is $38,944 to $42,893. So, what is the margin of error for this interval? Or I guess you should maybe tell me how you find it instead of just giving me a number.
Okay, so we're doing T star, right? So I guess we would use the T thing for like 250 degrees of freedom for the two-tailed thing at what's the point one whatever it is. The T star would be 1.651.
How about I just do this?
Well,
Oh.
well, I did something.
I don't have enough information to do that
Oh.
because you don't have the standard deviation.
Tis why I was confused.
So I was on the right
I was
track with
gonna
my
get
little
there. I was
calculator
gonna
thing,
get there.
except I added
I
them
wasn't
instead of
gonna get
subtracting them, and then I got a really big number, and then I was like, no, that's not.
Is that formula in the notes?
I don't think so.
Yeah, I was gonna say, I think the regular one is.
Yeah, that's why I was like, as he was going, I was like, I'm just gonna stop him right there. Because I was like, I don't think this one's in there.
So, I was about to say that.
Is that right with the cents on it?
I think so.
Okay.
Yes.
I mean, I guess it has to either be a whole dollar or 50 cents because those
Right,
numbers
right.
didn't have change on them, so.
Yeah.
Well, I guess I had found the average of those two.
All right. Consumer Reports tested 14 brands of vanilla yogurt and found the following numbers of calories per serving. Okay, so this is a table of how many calories each one has. So it's one list is all this is going to be. So check the assumptions and conditions for Inference. Be sure to plot your data in a histogram. So we will do that since, it's been a while. I guess so. It's just one. Yeah, anyways. All right, so are our assumptions and conditions met? less than 10%, random,
Yes.
Yeah.
independent,
Yeah.
Yes.
nearly normal.
I guess we'll have to check histogram.
We'll have to check that one. So for the moment, we'll say yes, but we'll look at it. So you need to go enter these numbers all in a list.
Second stack is this.
No, it's just.
Nope, just stat. You should have 14 numbers in your list when you're done.
Is this all going in one list? Or two?
One. Let's see if y'all remember how to make a stat plot or a histogram.
Oh, I got
That was like-
histogram.
That was like
Josh got a
second.
histogram. I was gonna say that was like unit 1 somewhere.
Yeah, I got one. Doesn't.
Oh, I got it. I got it.
Oh. The happiest. It's a little weird. It's supposed to be me too. I got that. She also got that.
I forgot how to make a histogram.
Make sure your histogram is using list 1.
How do you make one again?
Oh,
Did you do Zoom stat? Maybe check and make sure all your numbers are correct in your list and that like one didn't get typed in weird or something. What, Nathan?
How do you make a histogram again?
Second y equals.
Oh, it is L. Never mind. It wasn't L2.
And then you'll have to just turn the plot on and then go in
Which
it.
one is the histogram? The third one.
It's the one that looks like this.
And then how do I graph it? Do I use Zoom?
Zoom 9.
There we go. That's better.
Now, might not be
It's
perfect.
not beautiful,
Okay, but normal enough.
but no, that was not.
I didn't do anything.
Did you do it right?
Did you turn the plot on?
Are all your other plots off?
My calculator's being slow. It's loading.
Well, yeah, it takes a hot minute.
Oh, my plots were not on.
There you go. Only one plot, not all of them. If all of them are on, you're gonna have issues.
I got the histogram. Yeah, thanks.
Let's go. Shoot the and then just
Yeah, I'm still not
really? Can I try? Do the same calculator.
Now, for 95% confidence interval, okay, we don't know all this information yet, so we're going to do our T interval. But in this case, this is where it's going to be using stats instead of data. Okay, so on the last one we had data, now we have stats. We haven't found all this information yet. Yes.
Does the order matter?
No.
You said we're using what?
So go to second vars and then do T interval. Nope, I lied. That's not where it is. No, that's not where it is. Stat test. T interval.
They're trying to get me.
Who's trying to get you?
These people.
Or wait, we're
They
using
won't
data.
tell them
We
my
had
address.
stats on the last
Oh,
one.
Is that like your USPS?
Yes, they
your
said my
UPS
package
address?
can't be sent to can't be from the warehouse because incomplete address. They're trying to get me.
I get those all the time.
Oh,
So this one,
You're on L3.
I'm
data. Then list, whatever list you use. So mine's an L1. Frequency is 1. Confidence level is going to be 0.95.
Because you were using the wrong list.
I
Just like
changed
I
it to
was.
L1 the first time. I said that.
Now you're supposed to change it to L3. Your information was in L3.
Oh, it was?
Yeah.
Oh.
So my interval is 132.02 to 183.7. And you're going to notice it provides you with all this information now. Okay, I already knew that N was 14 because I counted up here beforehand. X bar is 157.86. S is 44.75. So then my degrees of freedom is 13. Now, once I have all this information, okay, I could do this by hand and check it, but you can also just, use the calculator for that. We'll just do part C tomorrow because the bell's about to ring. But we'll finish this tomorrow and probably look at the notes for the next chapter tomorrow. And then I really don't think we're going to be at school on Wednesday. So Thursday and Friday, we'll do examples for 24.
It said it's